much everyone I've seen before. Who's new for the first time?
Hey.
Say.
It's glad you're here.
Good to have you here. Welcome, welcome.
Good to be here section. All right.
Yeah. In fact, can you move over to no? Just, we don't want to mix with the old and the new. Anyways, it's good to have you here. Again, thank you, Weave. Always incredible gifts, hosts, I should say, and having us be here as a guest. Great food. Thank you. So you can give your thanks to Weave. You know, those that have been here a few times, last couple of years, I don't even have to say anything about Carson. The guy's just, he's the dude.
Watch the video for cloud native computing.
That actually was really good.
Now,
Of Kelsey Hightower.
yeah.
Yeah, I can't.
The only thing is that it was his mother-in-law that just kept on.
That might have been it.
You hired a quick farm?
Yeah.
Yeah.
Let's not go there.
Hey,
Still the highest. Still the highest, no matter how he got it.
Damn.
Biased.
But anyways, you know, he's amazing. I think there's an incredible interest in this. We are recording it. I think there was some stuff up here to sign up for the Slack channel. We'll put it on there afterwards again. Please sign up on the Forge Utah. There's a Kubernetes channel. Usually pretty friendly.
Oh, yeah.
You know?
Yeah. Talk about tabs and space.
Yeah, that's not good. Emacs and VI was a little bit interesting, but we already know who won that one, right? I mean, I don't even need to say it.
I don't even have that one.
You have it?
I was on there.
Anyways, and Brenda has been doing some fun things. So for our speaker, there's the Go pin, but now there is the Kubernetes meetup Utah Kubernetes statue. Thank you. Statue. So customized.
My own GitHub.
3D printed?
That's GitHub. And that's 3D printed, and that is the equivalent of an Oscar, maybe more.
I think so, yeah.
At least an Emmy. At least an Emmy. So anyways, thank you for.
Well.
I think we're going to do pretty much like normal present, but also if you have questions, interrupt, kind of go where you need to go.
Yeah, absolutely. It's depending on the demos and how fast we go. It's 45 minutes to an hour,
We've
like,
gone beyond.
we've gone beyond before. It won't be the longest one I've ever done.
What we promised to do is stop at 7:30, just to have a break. And then if he's through, fine. If not, then those that need to leave, go ahead.
Last time we did custom operator, it was 2.5 hours.
2.5 hours.
That was
a fun one.
Great going.
We stopped it after an hour, and we said you could leave anytime.
Absolutely.
Look at, and almost everybody stayed.
But the best stuff was after, man. But also during the presentation, if you need to leave, we understand that.
Yeah, you gotta go.
If you're really like that, that's fine. You can leave. You know, it's fine. No more food for them later on. Anyways, thank you. We are recording it, not live tonight. We're going to try to see if we can do that in the future. But we're going to record it, and we'll try to centralize some of the videos because we've had them in one area, but we'll talk about that. So anyways, cool. Thank you, Carson.
Well, all right, let's do it. I'd like to thank the Academy. This is really cool. I'm actually really into this. I'm going to go figure out something to talk about GoLang just to get the go for. It's going to be weird for you all on that side. I'm going to stand over here since most people are over here because I can point at the screen a lot. Everyone, can you guys still see? Just fine.
Social, it's fine.
Okay, I'm just going to stand. No, it's not because of a smell or anything. Not that there's a smell. Okay, so thanks for coming. This is all about Kubernetes operators, state-seeking infrastructure as code, which is a whole lot of title, but you'll see what I'm driving as we dive in. My name is Carson Anderson. Like I said, I work at CoinZoom. I'm on GitHub at Carsonoid. That's important because the source code for all the demos we're going to do, and we're going to do 4 demos, maybe 5 at the end, a 5th one at the end. I'm really excited about them. They're really cool. The code is all there as well as the slides, and everything I've ever done is out there. Every time I do a fancy presentation, all the SVG source, everything's on my GitHub. I'm also at Twitter at Carson_ops. I mostly only retweet smarter people than me, and occasionally tweet about like things that I'm presenting. Let's get into it. I'm going to start out with this slide, but I'm not actually going to read it because I feel like I have to start an operator talk with a what is an operator slide. And there's a whole lot of text out there in the world about what an operator is, but I don't even want to go over it because really an operator in Kubernetes terms is just one thing. It is a management pattern. It doesn't matter. It's not a specific framework. It's not a specific language. It's really just using Kubernetes constructs to manage our systems in a Kubernetes native way. And Kubernetes does operators internally a lot, and we'll kind of dig into that, but that's all it is. I'm going to go over a whole bunch of frameworks and languages, but again, the operator system is just a pattern. Instead of just saying why operators are really cool to you and just throwing it out there and saying you should use operators because they're the best thing in the world, we're going to actually build some software, try to deploy it a whole bunch, and we'll figure out where operators become useful, where just deploying software with raw YAML or lower level Kubernetes tools starts to suck, and why operators fix that for us. So I'm creating a quote unquote practical example. I don't like hello worlds. I think they're boring. So I always like to make something more interesting than a hello world, because hello worlds are never useful beyond just the academic idea of them. So we're going to deploy WIGM. And WIGM is a piece of software, quote unquote, that I wrote, and it stands for Wasteful Individual GIF Mirror. And it is really, really simple software. It is basically just NGINX with some code that runs in front of it to turn it into a custom server, quote unquote. The goals of every single WIGM deployment that we do are really simple, right? So we want to, and I'm going to keep looking at this because it's super laggy, so I feel like I have to keep making sure I'm talking about what's on there. WIGM is going to be a really basic web server. Every WIGM we deploy is, like I said, just NGINX. I want every server to host exactly one GIF and only one GIF. So every time, if I want to deploy 100 GIFs, I got to deploy 100 web servers configured 100 different ways. I'm going to make it really, really easy, hopefully, to deploy a lot of these because I'm doing one GIF per server, which means I better be really good at building servers. And as a bonus, I'm going to show you how I'm going to do this without building any dedicated Docker images, because building a Docker image for every new GIF I want to serve would suck really hard. And since it's a mirror, it's right there in the name, Wasteful Individual GIF Mirror, we're just going to pull it from some upstream and then serve it from a local cache. Every time I deploy a WIGM instance, we're going to give it a couple things. We're going to give it some environment variables, namely a name and a source link, right? So we're going to give it some pretty name to put on the web page and a link of the thing we're going to mirror. So some upstream GIF link that someone else is hosting, we're going to pull that down and then serve it locally. We're also going to make a couple operational decisions every single time we do this. We're going to decide, should we make a dedicated load balancer in the cloud for this GIF? Again, I'm going wasteful, why not? Let's go all the way out. Sometimes I want to be really wasteful and make a whole application load balancer just for one GIF. Or alternatively, or maybe together, I'm going to say, should I make a Kubernetes ingress resource for this GIF so I can do some host-based routing and go to a certain GIF based on the host I'm trying to go to? If you don't know what ingress is, you don't know what these services are, I'm going to kind of dig into those Kubernetes ideas before when we first deploy WIGMs with raw YAML. But let's get into it. Every time I deploy a WIGM server, it's going to put out a few things. Like the result of all of these inputs and business decisions are some Kubernetes resources. Primarily, it's going to be a Kubernetes deployment, a service that's going to be configured one way or another way depending on the business decisions, and maybe an ingress resource. Again, every single time I deploy WIGM, I want to say, here's your name and your link, and maybe make a load balancer, maybe make an ingress. So these bottom two change or don't exist at all depending on what you're deploying. Let's start with the WIGM server itself. And like I said, I don't want to build a dedicated Docker image for every single instance, and so we're going to do this with pure upstream NGINX. And it was inevitable. It's a talk about operators. The title of the software is WIGM, so it's all WIGM GIFs from here on out. This is it. This is the entirety of the quote-unquote software that I'm deploying. This is a super simple bash script that I'm going to inject into every container at runtime, and I'll show you how I do that. And it basically, you can step through it. It starts by saying, okay, first get curl, then change the directory NGINX is going to serve its content from. Get from our upstream link, get a local copy and call it WIGM GIF, no matter what the upstream link is. We're going to write with a here doc a super, super basic HTML page. If you don't know what here doc is, it's everything between these two EOFs is going to be written into this file. It's a really, really great bash construct that I highly encourage everyone to look at because it will save you a lot of ugliness of a billion echoes. If you're still doing that, look at here docs. And then at the end, we're going to actually start NGINX because I'm running this instead of the normal NGINX startup command. And so I need to make sure I actually start NGINX when I'm done setting it up. But this is it. You put this in an NGINX container and it's a WIGM server. So let's do it. Let's deploy a bunch of WIGMs. I'm going to do it in stages so we understand where operators come in and when they start to get really useful and really cool. So the first thing I'm going to do is the first thing everybody does when they're playing Kubernetes. We're going to deploy something with pure YAML because that's just how we all start developing our Kubernetes things. And there's nothing wrong with starting a pure YAML. In fact, it's the fastest way to iterate and figure out what in the heck am I even going to put into this cluster. But it's hopefully not the place you end up. So once we use YAML, we see like, okay, YAML is great, we can iterate quickly, but it's not great for managing lots and lots of deployments or even complex deployments. So we're gonna move on to something called Helm, which is a Kubernetes template engine. A lot of people have strong opinions about Helm, but it is very useful. It has some shortcomings, which we'll go over when I get into it, but it works pretty well for what it is. Once we kind of use Helm and figure out where it falls apart, we're gonna say, okay, let's finally get to the meat of the presentation. Let's get into operators, and let's build an operator to deploy these WIGM instances for us in a way cooler way than either YAML or Helm. I mean, it's better, but it's also just flat out cooler. We're gonna do it two different ways with operators, by the way. We're gonna deploy it with Metacontroller, where we don't write the whole operator. We just write the business logic. We basically write a webhook, and that's it as our operator. Then we're going to deploy it with this thing called the Operator SDK, which puts some nice sugar on top of the Golang SDK for Kubernetes and makes it a lot easier to kind of repeatedly build operators without having to understand all of the deeper level Golang constructs that you would use to build an operator from scratch. And I know because I've done a lot of Kubernetes operators from scratch, and I can tell you the SDK makes all of that a whole lot easier. In fact, it makes it, we're going to kind of, if we have some time at the end, I'm going to show you how you can take the Operator SDK and actually turn your Helm chart into an operator in a single command. And I think it just blew my mind when I did that. It's not a full-on operator, but it gets you a lot closer than pure Helm. So let's get into it. Let's start deploying WIGMs, and we're going to deploy them with pure YAML. That's where we always start. And if we do it with YAML, this is what you're doing, right? This is operator in Kubernetes. Running your clusters with YAML is copy, paste, and typing furiously. And all of the inevitable errors and typos and misconfigurations that come from that. But it's a great way to start.
No, I type right.
So this is what WIGM looks like if I'm deploying with YAML. This is everything in the directory. If you go check out the code right now and look at it, this is what you'd see. We've got our main resources.yaml, and I'll show you what's in there, but I've done YAML document separators because I'm gonna be copying and pasting this file. Every time I wanna say, well, here's my base definition of what a WIGM is. I need to release a release of it. Let's copy, paste, change the content of the YAML file and throw it to the cluster. And that's how a lot of people operate their clusters. It's sort of kind of the Kubernetes equivalent of version control by copying the file to file.1, file.2. Like, it kind of works, but it's really, there's way better ways to do it. Let's dig into the YAML, and I'm gonna spend a fair bit of time showing you the Kubernetes YAML for all the things WIGM's deploying. First, to kind of get you an idea, if you haven't used any of the Kubernetes things, what we're making, and also because if you look at this, you're gonna see this pattern over and over again. You're gonna see it in YAML, you'll see it in Helm, you'll see it with the operators. At the end of the day, you still have to define the same thing, whether you're using Helm or YAML or operators. You still have to define the Kubernetes objects, and they tend to follow a very similar pattern. You can kind of see the thing emerging over and over. So this is a Kubernetes deployment. And if you don't know, Kubernetes deployment's job is to basically, for you to define a container or set of containers and a number of replicas that you want in the cluster, and you put that in the Kubernetes cluster, and it ensures that whatever the definition of the containers you want deployed is, and the number that you want, it keeps that in sync. And it does all sorts of cool things like automated rollouts and rollbacks and great stuff, but primarily it's there to say, make 2 of a thing that looks like this, or make X of a thing that looks like that. So if we were to look inside of the YAML configuration in the Git code, you'd see that, okay, I put in bold all the things I have to replace. So every single time I do a deployment of my software using pure YAML, I'm gonna copy my main file, paste it somewhere new, and go find all of the things where name in all caps is there, and find and replace them with my editor or with sed, and hope that I don't have some place where name is in all caps somewhere else, but I don't actually want to replace it because it's part of like namespace or GIF name. And it's not bold, of course, when you're editing the text directly, so it's really hard to even look at it and see like, what am I supposed to change every time I make a new deployment? But it works. So I'm creating a basic deployment, giving it a name, some labels. There's a lot of replication in deployments where I'm saying the deployment has labels and the pods that it creates have another set of labels. If we dig further into this deployment, where I'm gonna kind of push away some of the higher code, you can see where we start actually defining the container I'm gonna deploy. So I want n number of this container. I'm gonna call it gift host. We're using pure NGINX every single time. This is where we put in our environment variables, where we say, this is the name of the GIF that we wanna serve. This is the link to the GIF we wanna serve. If we go further down, you'll see here's that command that I showed you earlier. Again, I'm snipping a lot of it out to fit it on the screen, but I'm just using a big old YAML string saying, yeah, the start command for this is all of my code that makes the web page and clones the GIF for me. And if you want to see all of that without all the stuff snippeted, you can go get it in the source code right So that's great. If in Kubernetes land, like once we've got this, we put it in the cluster, we would have a bunch of pods and containers running in the cluster with no way to get to them. And that's not super useful for serving diffs if you can't actually go to the web servers that are serving them. So what we need to do is we need to make a Kubernetes service. And the Kubernetes service is really simple. We'll give it, again, a name, a lot of finding and replacing that we have to do in here. Then we're going to tell it, okay, you need to find all of the pods that I've made in the cluster that have an app, a WIGM, and a GIF name of name. Right, so we're creating a bunch of pods, and then we're creating a service that is loosely coupled to them, saying this service should include all of the pods with this kind of label. Notice I've got a business decision here that's in code. Remember, one of the things I wanted to do was decide, am I going to create a dedicated load balancer for this GIF or not? And for me to do that decision, I have to go and change my source code and uncomment a section. Finding and replacing is one thing. Changing chunks of code is way harder to do with sed or any, your editor tools. But it works. We'll be able to go and uncomment this and change our mind about things. If we go further on and look at our ingress rules are where you tell Kubernetes, okay, yeah, I can make a service that points to these containers, but what if I want to have a lot of different users coming into the same load balancer, but route them to different services on the back end based on their HTTP host? It's something that you typically add into a Kubernetes cluster. It doesn't come with them all by just out of the box, but it's a really, really common thing you put in Kubernetes clusters. So I'm going to say, maybe for every single WIGM deployment, again, I've got a comment here at the top that says, hey, if you don't want to make an ingress rule, delete this part of the file. Like that's my deployment mechanism. And it's a crappy one, but it works. And we're going to say anytime you come into the cluster and you're coming into the main ingress endpoint, if you're coming to whatever.wigm.carsonanderson.com, you can actually route it to this WIGM service. So we've got a deployment making pods, a service pointing to those pods, and maybe mapping a host name into that service into those pods. This is kind of like the boilerplate Kubernetes deployment that you'll do. Probably the very first thing you'll do in Kubernetes if you're going to serve something with it. So I'm going to do a YAML release, and I'm going to walk through a couple releases, and then we'll actually do it in the demo. So if I was going to do a release, and get used to the screen, every time we do a release, I'm going to kind of break down the information the same way. We're going to give it a name and a link, and we're going to say whatever the default decisions of the code are for our business decisions of create a load balancer, create an ingress rule, do those. So we're going to try to keep it as simple as possible, minimal input. So our release process is what with YAML? It's copy, paste, do a bunch of editing, and throw the YAML at the cluster and hope that it works. And we're going to do that over and over again for every release. So if we're doing our first release, we're going to copy, paste, change all the things, Q control create. If I was going to do a second release and be more complicated, say, okay, I'm not just going to do the default things in the code, but I want to make some different business decisions. In fact, I'm going to do the opposite of the default for both of my decisions. I'm going to make my deployment as complicated as possible now. The process gets uglier because it's copy, paste, find and replace, go into this one piece of code and uncomment a line, go into this other piece of code and take the whole section out. And that's just a terrible way to deploy a lot of things. Like, it's really hard to track what you've already done. It's hard to go back 6 months later and look at a thing and say, now what decisions did I make and how did I turn this on and off again? But it's fine. It's a way that you can get started. The update process is even worse. The update process with YAML is go in and edit the raw code, throw it in the cluster, and hope. Like if you change your mind and say, actually, I did want an ingress rule for this, you got to go remember what section of YAML did I delete, and how do I put that back with the right options and make sure you create it correct. And it's terrible.
You just copy it from another one.
Right, yeah, no, that's the solution a lot of people come up with. And it's a crappy way to run a product. So let's do a demo and kind of see how this works and how it starts falling apart.
We had people do that and they copied the health checks that didn't exist, so then it kept restarting.
Because as soon as you're copying it manually, you're going to make a mistake. Yes. It's a great way to develop, not a way to run anything. So what I've got here at the top left is I'm going to start and create a Kubernetes cluster from scratch. I use this thing called K3S, which is fantastic, and I will continue to tell people to use it till the end of my days. It's Kubernetes, but less. It's basically a single binary that is everything you need to run a Kubernetes cluster that completely works without having to have basically anything but a Linux server. In fact, I'm doing it all in Docker. So every single time I make a new Kubernetes cluster, I'm just saying Docker create and then Docker delete, and I've got a cluster coming up and down all day long. I'd also encourage you to look at K3D, and I'll put some links at the end. K3D is a way to manage creating K3S Kubernetes clusters in Docker with a single tool. So if you think it's hard to get started with the Kubernetes cluster, it used to be. It used to be a pain in the butt. Even Minikube used to suck. But with K3s, like, that's it. And you can go pull down this code, change it in this directory, and as long as you've got Docker and Docker Compose, you can bring up Kubernetes cluster and run this demo yourself. I want to make it, it was really important to me when I did these demos that anybody could run them with minimal tooling required. So I've got this cluster. I'm watching things every second so that we can see as I create things how they work. We run the demo here. And it's all automated, so I don't have to type. I don't do anything manual that I don't have to do, even my demos. So here's our first release. Remember, release number 1 is default business decisions. So I'm going to copy the resources.yaml and change it, put it into the releases directory. Now I'm going to run a bunch of seds and edit the name to the name that I want, edit the GIF link to the link that I want. And that's fine. Like, it's easy enough to find and replace a single thing with sed. So I'm going to use kubectl and put that into my cluster. Yay! I've deployed WIGM. I've got a deployment up here. I've got the service, the ingress rule, the deployment, and the pods that came from the deployment. So we deployed something in Kubernetes by copying and pasting YAML, like big whoop. Let's do the harder one. Let's do the one where we make the deployment as hard as possible and we're changing things from all of the defaults to the opposites. So the same thing, I'm going to copy my resources to a new release. I'm going to do sed on the things that I can do sed on. And now I have to put some comments into myself to say, oh yeah, you want to do something different? Remember to go edit this code. So I'll do it. I'll go into releases and I'm going to go find Hold'em and I'm going to go down and find this section of code and uncomment it just to show you. I mean, this is painful even doing once. And delete that other section of code. And this is easy for me because it's a simple thing that I'm editing. But imagine if you did one and then you came back 6 months later after not looking at this project. Would you remember all the things that you had to do to like change your mind about a decision? So I've done that. And now if I go back, I manually edit my files. I hit enter. We kubectl, put it in the cluster, and we got what I wanted, right? Notice there's only one ingress rule, that second section down, because I took that ingress section out. You'll also notice that the load balancer here is of type load balancer, where if I was running this not on a local K3s cluster, but in Amazon or Google, it would be spinning up a dedicated load balancer in the cloud for me, right? I've changed some inputs, and I did that by doing a bunch of manual editing, and it works, but it's kind of gross. And just to take this all the way to the end before we finish the demo, let's show you that you can indeed curl. If I curl into my cluster and give it a specific host name, you can see that, yes, I went to yaml-release.wigm, and look, I got YAML release as my title. You can't really see the image, but you'll see it in a second. So we know that hostname proxying works. We can use kubectl to port forward into our cluster, hit refresh. Yay! We've got our WIGM server up. But I don't like that name. Like, I've got this deployment up, I'm looking at this image, but that's really not a super human-friendly name that I put up here at the top. So if I wanted to go change that, let's see what I have to do. That's right. I have to come over here, and kubectl, kubectl, edit deployment, WIGM, YAML release. I have to go find the right section of this big file that's now got a lot more metadata in it because I put it in the cluster. So now there's all sorts of stuff in here that I didn't even have in there. And go to the right section of this container, which is actually now below the script. But it works. I save that. Kubernetes has immediately seen that my deployment has changed and has started to seek the state, right? I've edited a value of my deployment. It's rolling out new pods, and I'm being really annoying about pointing this out because guess what? Deployments are an operator. Like, operators aren't something that we came up with as Kubernetes users. We're just extending what Kubernetes is already doing internally, right? We've already got, in fact, we just used, depending on how you count it, 3 or 4 different operators making that one change. I changed my deployment, and internally, Kubernetes has a component that is an operator that's watching deployments and detecting when they change, and then rolling out another Kubernetes resource called the repos that then rolls out pods. So we actually used about 2 or 3 operators that were internal to Kubernetes just now. So when you kind of like hear about operators, you think, oh, it's this weird thing that all these Kubernetes freaks are doing. It's actually, no, it's something that's internal to the software. We're just extending it to our own products. But that worked. If I go finish the last demo, and I curl that again, we should get a prettier host name. Look at that. We got a new host name, but this sucks. And if I do another proxy connection, yeah. So that worked. It sucks, but it absolutely worked, right? That's how a lot of people manage their Kubernetes clusters. If I wanted to go roll back, by the way, if I wanted to say, oh, that name actually, I shouldn't have changed that name to that, what it was. Let me roll back to the old value. Does anybody, like, I have to go actually remember what the old value is. Like, there's no real tracking of that. It's just kind of, the whole thing just kind of sucks. So I'm not going to do the rest of it. This one says, go back and remember the first upgrade where you didn't enable ingress? Well, go enable it again. I put a lot of stuff in the demo here, basically explaining like, some of these simple changes are easy enough to do manually. But if I were to say, point out this Kubernetes YAML, or the Kubernetes Helm release, the one where we said, okay, create this other deployment. We don't want to enable ingress right now. If you came back 6 months later and said, actually, I do want to enable ingress, it becomes just absolutely impossible to remember what you've deployed and put that reliably back into the cluster. So I'm going to stop yakking about YAML and let's go into the cool stuff. I'm sick of talking about lame stuff. All right. Okay. And what I'm going to do actually is get started real quick on the other cluster because Helm can take a little while to start if the internet's not. There we go. So we did some Kubernetes deployments. We saw that WIGM does work and that it's easy enough to understand the YAML, but actually changing our mind and doing a lot of those, like that was fine with 2. You can imagine if I had 100 of those where I made 100 different decisions and I'm trying to track what those decisions are. There's no central source of what the decisions were. There's no real way to change those without having to change code. So let's move on to Helm. This is kind of the next step that everybody goes to when they're working with Kubernetes because it's a project that's been pushed a lot by the CNCF. Say, okay, well, you don't want to do raw YAML, start templatizing your YAML. And that's actually just fine. Like, there's nothing wrong with Helm. It has some shortcomings we'll get into. And in fact, the shortcomings are kind of why I picked this GIF. You know anything about Simpsons or this GIF? 2 seconds after the GIF ends, he gets punched in the face by his wife. And that's why I feel like, that's what I'm getting into with Helm. Like, you're going to strut along, it's going to feel great, and be like, yes, I'm working with Helm, I've templatized all my YAML, and then you're going to hit a brick wall where it just can't be as nuanced or can't do the things that you want it to do. You may not. It may only be for us people that are deploying complex systems in Kubernetes, but eventually I feel like it kind of falls short. It has some shortcomings, and we'll get into that. So this is the WIGM Helm infrastructure. There's a lot more here than raw YAML, but that's kind of a good thing in my book. So because I'm not relying on copy and paste as my distribution mechanism, I actually went ahead and split my deployment, ingress, and service files into their own files because I'm not trying to make it easy to copy and paste anymore, so I can actually make things more readable instead of building my code based on my deployment mechanism. With Helm, you basically make a couple things. You make a chart.yaml. I won't show you. It just has some metadata about the chart. You make some default values, which I will show you. And every time I want to do a new WIGM deployment, I'm going to create a new values file that specifies each deployment's individual overrides. So this is the values file for Helm. This is the default values file. And what I want to point out here is I already had a slide earlier on that said, here's what WIGM takes in. Here's the environment variables it takes. Here's the business decisions that we're going to make. And this is kind of a YAML representation of that, right? It's all in one file. I can see immediately all of my inputs and all of my decisions by looking at one file. And every time I do a new deployment, I can copy this file, change the contents of it, and immediately look at it. And without having to read through code and try to understand what I've deleted and what I've changed, I can just see, here's the inputs, here's the decisions. It's all very, very clear. I can come back at this later and know exactly every decision that I made because it's right there in the code. It's not pieces of code that have been deleted or changed. I will point out, so we've got our GIF name and link. Those are the environment variables. We've also got some Booleans here, whether we're not going to create a dedicated load balancer and whether or not we're going to create an ingress rule. So if we go dig into the templates now, this is the same YAML from before, except for all the things that were in bold that I was relying on sed to find and replace, I've replaced with templatized variable substitution. So I've got kind of immediate flexibility, and it's way more obvious, even without the bold, if you were to go look at this file, what things are variable and what things aren't. I'll also point out that I'm doing some fancy stuff in here. I can use some features of Helm to do smart defaulting. You'll notice at the top that I'm using a .release.name instead of the GIF name for my resources. And that's because every time you release Helm, you give it a name of the release. And I'm saying, why, I've already got a release name, why would I use a GIF name? This allows me to have much fancier GIF names without having to worry about the difference between like whether or not it's going to be Kubernetes friendly in the resource type name. So we can dig further in. Mostly what I'm pointing out with the service, again, we find and replace all the things. And you'll see our business decision is no longer a comment that says, delete this if you change your mind about this. It is a if statement, which is what a decision is. It's not changing the code, it's an if. We go further into ingress, and you'll notice the entire thing is wrapped in an if statement. So if I change my mind about a business decision, it will just not render this chunk of the code. And if I go change it back later, it will just re-render this chunk of the code. I don't have to figure out what's missing and copy and paste it and hope that I didn't screw up. So let's do a Helm release. We're going to do the simplest possible one again, where I'm just saying give it a name and a link and keep all of the default decisions from the code. This is a much cleaner process immediately, right? You remember the YAML was copy and paste, do all these ugly sets, go change these files. Now the process is create a YAML file for the release. And I'm only setting the things I want to override from the default here. So I can have very, very minimal input because I'm saying I don't even need a name. I'm going to use the release name if it doesn't provide one. I just need a link. I'm using here docs again to make the file just so it's all clear here, but you can make it with a regular editor or whatever you want to do. Then we do a Helm install. This is where I'm passing it a release name, which is typically more Kubernetes friendly. It's not going to have weird characters and that kind of stuff. And I'm saying, okay, when you install from this current directory, look for these values and apply them over the top of the default. So this is immediately more readable, the things we've made and the decisions we've made when we're deploying this release. We go further in and say, okay, well, let's do a more complicated. Let's do the most complicated release. It doesn't actually get that much more complicated when it's time to deploy. We're going to write a file, and this time we're putting more data in the file to override the defaults more. This is, again, way clearer to understand the decisions I've made and what I'm putting into my software and what I'm expecting out of it. Again, I'm doing a Helm install. This time I'm not passing a release name, and Helm will just generate one for me. And we'll see that in action in a second. The update process is where it also really starts to shine. Instead of going in and copying, pasting code, or editing a bunch of things live in the cluster, I can go update my release file. I'm recreating it here, but you could go pull it up and change the name and do a Helm upgrade and reapply it to the cluster. And I don't have to go edit code. I'm just changing the inputs into the rendering engine. Finally, I'm going to do kind of a bonus thing with Helm here, where I don't actually need a values file. Like the values file is nice for having a record of things, but you don't need it. So notice I'm not even giving it a name here. You can actually, with Helm, say, okay, I want to install from the templates in the current directory, and I'm just going to do a -- set and set all my values in line. You can see how you can take this command, take a file full of a list of 100 links, and spin out 100 WIGM deployments in a batch loop in no time at all. Something that's basically would be impossible otherwise, or not impossible, but it'd be a super pain in the butt with raw YAML. So I think this is just a really cool thing. Let's go into the Helm demo. Okay, so I created another new fresh cluster. This cluster bootstraps Helm in for me because Helm is a third party. This is one of the things that it comes great, but it has some components you have to install into your cluster, and you have to have some extra access into those components. YAML basically only requires Kubernetes, and using an operator, which we'll get into, only requires the operator to be running, and then you interact exclusively with Kubernetes. Helm's kind of downfall is that you interact with Helm tools. So it's this extra set of tools that you have to have in your pipeline, an extra set of configuration, an extra set of things that have to run in your cluster, rather than just being a purely Kubernetes interface. And you'll see what I mean when we get into deploying things with an operator. But if I go ahead and start the demo, you'll see I've added the tiller deployment, so I know that tiller is a Helm component, the component that has to be in the cluster for me to do Helm things. And I know that's running, so I'm going to start the release. We'll do our first one. Again, the whole process isn't copy, paste, find, and replace. It is create a file, and then use Helm, and throw that at the cluster. There you go. And our things showed up in the cluster. They got all of our release names, and it's the same output as our YAML, but the way we did it was way cleaner and way easier to understand. We're going to go continue the release process here. Let's do our more complicated release. Notice this time I don't have to open up a new tab. go to the code, find the right section of the code and change it. Like I'm doing the same second release I did in the earlier demo, but it's all just by making one file with different inputs. Go to the cluster, and there you go. Notice I didn't get an ingress rule, just like last time. I didn't get an ingress, and I have a load balancer type service, but I did that by just changing my values, and it's very clear what I did, and I didn't have to go monking in the code to do that. Finally, the kind of bonus one where I deploy a release with just a link, and you'll see that it shows up. This time it got a randomly generated name for a virtuous fox, but again, just doing all the defaults, overriding the one thing I want to override, and it's so much easier than copying and pasting YAML. Let's move on to show you the curls again, to show that those work. So there we go, I'm curling in, ingress still works. We proxy in again. There we go. We go further down and want to do an upgrade. This time the upgrade isn't pull up another tab, Q control edit, find the right section that I want to upgrade. It is change the values file and then run the upgrade. And now it's up. You can see if I zoom out just a bit more. There we go. And if we proxy in, we'll get a fancier host name. Look at that. And I never had to edit code. I just changed my inputs and reran the tools. So now let's do something that happens where I'm going to accidentally delete something. Sometimes things hopefully things get accidentally deleted, but they often drift from your desired configuration. Like in the real world, I've had very, very rare experience of things getting just wiped. It does happen. But very often someone says, I'm debugging this problem. I'm gonna go into this deployment and I'm gonna add this environment variable so I can debug it. And then it's drifted from your exact configuration. And later that environment variable turns out to cause some big problem for you and you didn't know because you just drifted silently. And Helm, as cool as it is and how it's as easy as it is, you can see it's much easier than doing raw YAML, it's not gonna help me with drift, right? I've deleted my service and you notice I should have 3 services, I only have 2. And if I try to go in and proxy into that service that I deleted, it's not gonna work because the service isn't there. And it's broken, and I'm not gonna find out it's broken until someone complains, and the way I'm gonna fix it is I'm gonna have to go manually have someone run a Helm update and figure out which one's broken and fix it, and it happens way after the break happens. So that's kind of where Helm starts to fall apart, is it's not state seeking, right? You can already see, like, it's kind of cool, but I needed an extra tool set. And it definitely doesn't keep things in line with what I expect. And it really doesn't have any Kubernetes native way of reporting back to me all of my deployments, right? So I just did 3 Helm deployments. And the only way I know I did 3 Helm deployments is because I'm looking in the cluster and I can see, I'd say, well, there's 3 services here, so therefore I did 3 deployments, right? There's no central data store that says, oh, here's all the WIGMs you've ever deployed and everything about them. That data is scattered amongst all the files that I've made. And that's where Kubernetes operators really take this to the final level. Let me go ahead and clean this up. But I'm not going to tell you not to use Helm. I'm not going to tell you not to use YAML because you got to start there. And then Helm's a fine way to go. In fact, if you really just want the state seeking stuff, I'll show you at the end how you can turn your Helm charts into an operator in a single command, which I think is really great. But let's get into operators because this is where it gets really cool. So operators are where you are really, really managing your infrastructure with just Kubernetes. It's all state seeking. It's all using Kubernetes as the central data store, and it's super fast and super cool. And this is how I feel every time I'm deploying anything on an operator. It's just absolutely fantastic. Domo, in fact, when I did work for Domo, we went as far as to deploy all of our Kubernetes nodes as custom resources. So if we wanted to make more capacity in the cluster, I didn't go into whatever cloud that cluster happened to exist in, because we were in 3 clouds. I went in and made a Kubernetes resource, said I need more capacity, made it in the cloud. So I never had to leave the cluster to do anything with the cluster, and that was really powerful. So the principle of an operator, no matter what tool you use, what SDK, what language, they're all the same. It's a really, really simple pattern. It is watch the current state, seek to the desired state, and then report on where you're at in that process. It's just a state machine. Like operators are really just super, super fancy state machines. So we're gonna watch custom resources, and I'll get into that in a second, but it's a Kubernetes construct where we can define custom things in the Kubernetes API. We're also going to watch all of our child and objects. We're going to then create, update, delete things in Kubernetes or elsewhere. There's some really cool tools out there where you use Kubernetes custom resources and an operator to make things in the cloud directly. I think Amazon's got one for sure, and Google's got a beta one where you're like, oh, I need a database in this managed service in Google. We just make a Kubernetes object and ask for a database, and it'll make one for me. Instead of going out, again, instead of going out into the cloud and doing these things, just ask the cluster for them and never have to leave the comfort of the cluster. Finally, you're gonna, and this is another big one that you don't get from Helm, you're gonna report the state of where you're at in your state seeking so that other tools can consume not just what you want, but where you're at in that process. You just do that over and over again. This watch, seek, report, you just keep doing that until everything's in the state that you want it, and that's an operator, whether it's a custom operator or one that Kubernetes has built in. So every operator, no matter what language you're going to use or what toolkit, they're all going to basically operate on custom resource definitions in Kubernetes. And this is all you need in Kubernetes to have the API suddenly understand an entirely new type of thing. When I first, I'm still, every time I use these, I think they're like the coolest thing ever. I've got the Kubernetes API. It's got RBAC, it's got event watching, updates, deletes, it's got all this kind of basic functionality for built-in resources. But I can create a YAML like this. In this case, I'm saying, create these things called WIGMs at carsonanderson.com. They're giving it a bunch of metadata. The exact format of this is a bit verbose, but it's one pretty small file. I throw this to the Kubernetes cluster, and the very next second, I can kube control get WIGM, or I can kube control delete WIGMs, or kube control create WIGMs. It just blows my mind how easy it is to use the Kubernetes API for arbitrary things. So if we did that, the content, this is just describing and telling Kubernetes, hey, we want to have a new custom thing that we're going to work with in the API, but it's not actually the content of the custom things. So the content of them, we've actually already kind of made. If you remember the values file in Helm, where we said, okay, let's take all of our inputs and decisions and put them in YAML. Well, if you were to dress up that with a bunch of Kubernetes metadata, and this looks a lot like the deployments and services and ingress, this is a custom resource. It's really just YAML nested under a Kubernetes specification. Just enough to tell the API, hey, I'm trying to operate on a thing of this type with this metadata. Combine this past section with the next section, and you can create a custom resource definition saying, expect WIGM gets to exist, and you immediately put one into the cluster. If I did that in a cluster without an operator running, it would work, but it's not gonna actually do anything with this data, right? This is creating a data store and a really cool API into that data store, but it's not actually seeking the state. And the operator is the part that makes this true. So I'm gonna start kind of backwards, and we're gonna start with how you would deploy something using an operator, and then I'm gonna go through building them. And the reason I'm doing that is, I don't actually care as a consumer of an operator, really anything other than what does the YAML look like. It could be serviced by any sort of backend system. I don't actually care. It's kind of like talking to a web server. When you pull up a browser, and you go to google.com, do you actually care what backend service is creating that web page for you and serving it to you? No, you just have a standard interface and a way that you talk to it, and you get results back. And that's the same thing with operators. So no matter how we do the operators, and we'll do it one or two or three ways, it's going to be the same release process. And the process is really, really simple. It's a lot like the Helm process, except we're making a full Kubernetes document instead of just a values file, right? So we're just going to write a whole file. We're going to give it the information that we need and the metadata to tell Kubernetes how to work with it. And then we're going to use kube control to throw it to the cluster. We won't always use kube control. In fact, you could use any Kubernetes aware API SDK and put a custom resource into Kubernetes. This is kind of where it really gets cool. I'm going to use kube control because it's kind of the lowest common denominator. But one of my favorite things about having an operator is suddenly I don't need to have whatever weird tool I'm using to manage my infrastructure installed locally. I don't have to have Helm installed. I don't have to have all the Helm templates. I don't have to have all the values files locally in order for me to apply some change. I just have to have API access to the Kubernetes API and something that works with it. But I will use kube control in the demos. But if we throw that at the cluster, it would work. If we did our really complicated deployment, again, it's just like the Helm deployment. It's just as easy. I'd say a bit easier again because I don't need any other tools but Kubernetes tools. So I'm going to create the file, and I'm going to kube control apply into the cluster, and I will expect a WIGM deployment to come back for me. Updates are also where I think it just gets really cool because it's not, again, it's not get Helm, get the tools, get the templates, all that garbage. It is update the release and throw it at the cluster. And that right now I'm doing it in the example by creating a new file and kube control applying it. But you can do a kube control patch. You can use kube control edit to edit in line and change the resource. Again, just using pure Kubernetes API interaction, you can change your mind without needing any other tools. This makes it infinitely easier to plug your system into like a CI pipeline. because a new version change, or a version change or an environment variable change, imagine you've got some software you're deploying in Kubernetes, and you've got one environment variable that's referenced in 2 or 3 places, and I know there are other ways to handle that, but imagine you put it manually in 3 deployments. If you want to put that in CI, you have to have your CI system know every time I change one environment variable, change these 3 places. But if that was in a custom resource, your CI system can just cube control patch that custom resource and walk away and just assume the operator is going to do whatever it takes to make that true. So I think this is, and you'll see this is just where it gets really fun. So let's build WIGM with Metacontroller. Metacontroller is a great way to start building operators. It doesn't have all of the power of building your own from scratch, but it gives you a ton of power. So Metacontroller, like I said, no matter what the operator is that you write, they follow this pattern: watch, seek, report. The difference with Metacontroller is you notice these extra arrows where Metacontroller is doing the bulk of the Kubernetes lifting for you. Metacontroller is watching Kubernetes resources. It's calling your hook with all of the information about the current state of the cluster. It reads all that data back from your hook and applies it to the cluster and updates the status. So the cool thing about Metacontroller is I only write this tiny middle section here where I do the business logic of give me the current state and I'll spit out the desired state. And it does all the Kubernetes plumbing for you. So in order to get Metacontroller going in a cluster, it is kind of like Helm. It's another thing you have to have in your cluster because it does all the Kubernetes interfacing for you. So you need to install Metacontroller into your cluster and then somewhere run an actual HTTP server to process this webhook that it's going to call in. But it can end up being really simple. This is, if you dig in, this is a kind of a selection of what the Metacontroller deployment looks like in the code. It's pretty simple. We have the actual code, the YAML file to deploy Metacontroller in the cluster. Then we have the YAML file to deploy the controller. This is kind of an ongoing problem, by the way. You notice I'm back at YAML, because it's the lowest common denominator. Inevitably, we kind of end up going back to YAML to kickstart just the operators. Red Hat's trying to solve that in their, what's their cloud? What's the Red Hat cloud? Yeah. So they've got an operator of operators that they run on, if you get an OpenShift Kubernetes cluster, where you actually register your operator in their registry and you can go into their GUI. I don't know how full-fledged it is. I've seen early demos of it, and it's a cool idea where it's oh, I want the etcd operator, the MySQL operator, and the WIGM operator. Let me just go in their GUI and click enable, enable, enable. And then you really only need one operator to rule them all, and the rest are completely done in Kubernetes. But again, lowest common denominator, our examples deploy Metacontroller and our actual webhook server with YAML. But we just assume that doesn't change as much as our WIGMs. And then I've also got the controller Python code. I'm going to show you this. Don't get too overwhelmed by all this code. This is a whole bunch of garbage. This is Metacontroller. Notice Metacontroller itself up there at the top. It's configured with a custom resource. So Metacontroller is helping you work with custom resources, and all its configuration is a custom resource. The bulk of this is, I'm going to point out in bold, we're saying watch WIGM GIF resources, and we want to watch deployment, service, and ingress resources that are children of any WIGM GIF, right? So there's a whole lot of code here, but essentially we're saying watch this and any of these that it makes. So it's not as complex as it looks. We also have the URL that we're saying anytime any of those things change, call this endpoint and post the body of the current cluster state to that endpoint. So if we go into the controller code, again, I'm obfuscating a whole bunch of it, but when I'm writing this webhook controller for Metacontroller, I really only write one function. I write the sync function. I'm serving one endpoint, and that endpoint's job is to take in the parent object, which in our case is that WIGM GIF object. It's going to take a list of children objects. So it's going to, for WIGM GIFs, it's going to be a service, deployment, maybe an ingress rule. And then it's going to do some calculation and return the current state based on what was passed to it, and then the desired state. So really, it's like I said, you don't have to worry about Kubernetes at all in this. You're just going to say, I'm going to get a post body that is the current state, and I need to spit out all the JSON that would describe what I desire to be the actual state of the cluster. So it's just that kind of the really deep business logic of take in the information and put out what you want. So you'll see we're going to create the children object here. We're also going to do one of our if statements to say, okay, if in this parent WIGM, in the spec section, we said the ingress was enabled true, then add this ingress object into the children, otherwise don't. So our business decision when we move into an operator is still an if statement. We're still not going to ever edit code. Once we get out of YAML, we're never editing code again. So it's as easy as that. Moving on, I've kind of going to breeze by a lot of this because it's a little repetitious, but you can see this is kind of the same thing you've seen with YAML and Helm, right? It's the same deployment we were looking at earlier. It's the same deployment I showed you before. The difference is instead of having to either write it in Helm, or sorry, write it in YAML or use Helm to render YAML, now I have all of the power of Python to generate this data structure. And right now I'm just doing very, very simple string replacement and variable substitution. But you can imagine if I wanted to have this GIF source link come from some third party, what if every time I deployed a WIGM, I just created an object with no information, and I wanted it to just go find a random GIF for me and make a WIGM deployment with a random GIF? I couldn't do that in Helm, right? I couldn't, like Helm has to have an input, and it has to eventually generate YAML. But once I'm in Python, I can generate any part of this specification with Python code, right? So the kind of the environment variable one is a bit contrived, but you can imagine like if somebody says, oh yeah, we want to make sure you always have X labels on every single thing you create. That's hard to manage in Helm, but it's really easy in Python when you create this labels object to say, oh yeah, call this other API that's going to serve all the default labels and merge it in with what I want, and I never have to think about it again. I'm in code. I can do way more flexible things than I could ever do with trying to just use the template engine to render some YAML. It's also great because you get some, you don't get type safety, but you get kind of some idea that you're building valid things. Like problem with Helm is you miss a space somewhere. It's just like YAML. You miss a space somewhere, you go to render it, throw it at the cluster, and be like, oh yeah, no, this can't be a dictionary here, or it has to be a list. Or at least with Python, you're going to get a lot of that. It just won't build if you've got bad data structures. So it's not quite type safety. We'll get there, but it's some kind of safety. If we get further into the service section, this is that get service function. You can see it's a lot like the service we were building before. I'm still doing variable substitution, but I've still got my if, or my business decision in an if statement. If we go further on in the ingress, I've kind of put that business decision from the very first page up, just in case you forgot. We said, if ingress is enabled, call this function and add it to children. If not, don't even hit this branch of the code. So we haven't lost any functionality for sure going into Metacontroller. In fact, like I said, I think you've gained a ton by being in a proper language where you can do a lot more things than with render. So let's do Metacontroller and our first WIGM deployment with an actual controller. I should have brought up this. All right, here we go. So this will take a second because it does have to download Metacontroller. Is everybody following me so far? Everybody like getting what we're deploying? Why this is kind of like super useful? I don't know. I hate copying and pasting YAML. I hate doing anything manually that I can't script. So this is really running my whole infrastructure off of the same toolkit, and it's all automated, and I don't have to ever do anything manually. So you see, the cluster's coming up. I am running Metacontroller. That's actually going to plug into Kubernetes and watch for all of the configured events that I've told it to watch. And then every time those change, it's going to call to this WIGM controller that I put into the cluster as well. And I've done that with pretty much raw Kubernetes resources. If you dig into the code, I think it's pretty cool. I'm not even, the WIGM controller, if you actually dig into it, as an aside, is just the Upstream Python image with some code injected on top of it in Kubernetes. So I'm not even building a custom image for WIGM because I don't need to. I'm doing a lot of, like, Kubernetes has the idea of I can create a config map and put some code in there. It's limited to like a meg, but the current controller is way under a meg. And then just say, okay, run this Python, stick this file in there and start it. And I do that a lot to cheat having to make custom images if I just need to add a tiny script into an image. So if you're curious about how that works, you can go look at the WIGM code and see exactly how the operator is built. But it's up and going, so let's do our demo. In fact, I'm going to go out quite a bit, unfortunately, for this. Okay, so we're doing our first release. You can see that it's a lot like creating the values file. I'm just creating a whole Kubernetes object instead of a single file or a single bit of data. We use kubectl, throw it at the cluster, and we're going to see things showing up. But most importantly, like you've seen things show up before, that's fine. Sector refresh. What I really want to point out is this WIGM GIF section that never existed before. Because WIGM GIF definitions are in Kubernetes now and not in some file on my file system, they have a status section. They have a little section at the bottom of the Kubernetes resource that holds status information, and I can do some special stuff on the output and say, okay, every time you give me all the WIGM gifts, create a column in the output for whether or not I made a deployment, which in our case is always true, whether or not I made a service, what kind of service this WIGM GIF consists of, and whether or not we made ingress. And that's the current live status. So when I first deploy a new WIGM GIF and nothing's created, that'll actually be, all of those status fields will be empty. But as they populate and as they change, I can really easily, and you can imagine if you had 100 different WIGM servers deployed, you could just look down this list and instantly know every single WIGM deployment you have and every decision you've made. It's really easy to parse, understand output. So let's do another release. We're going to do our inverted business decisions. Again, this one is just as easy as before. We write this file, change our decisions, keep control throughout of the cluster. Let's curl it. And we've got a release. I'm actually going to go back. Because remember, this is where you can see the difference. Remember, we've been doing two deployments every single time. Default decisions, inverted decisions. Here you can actually see that the decisions you made and that they're different right there in the kube control output. And this is kube control, but anything in the read Kubernetes API can go slurp that status information and display it to you. So now again, all my decisions are clear as day, what I've made and the status of those. If I go in, let's proxy in, see how that works. So there we go. We're going to do the same thing we've been doing the whole time, change that ugly name. Again, I'm just going to rewrite the file and do a kube control apply. It should be rolling out those changes, and it is. There you can see one's terminating, and the new ones are up. If I curl these, we'll get our new name. If I proxy, we'll get our new name. I'm also going to show you one last bonus thing here. Let's curl that second deployment. Let's curl satisfied.wigmgif.com. And you notice I got a 404 because I didn't make an ingress rule for this. That's that second deployment where I said explicitly, don't make an ingress rule for this deployment. I could go, if I was curious and trying to debug this, someone's like, oh, this website isn't working. I can go look and say, oh yeah, satisfied says ingress created is false. So of course you can't go to satisfied.wigmgif, etc. But if I wanted to change that, say I wanted to change that from some external service, and I didn't have the Kubernetes YAML, I didn't know the contents of the rest of the WIGM YAML that I deployed, I could actually get fancier and use kube control patch, where instead of rewriting the whole YAML or having to go in and kube control edit, I could say, oh yeah, that's right, I really wanted ingress. What's that?
Oh, that command to patch is super simple.
The patch pane is ugly, but it's still way better. You can see how you could put this behind a button somewhere on a web page. You probably wouldn't be shelling out to kube control, but you could do an HTTP patch and patch it this little bit of data saying, I don't care what the rest of the settings were for this WIGM deployment. I don't care what the name was or the link. Just change this one attribute from this one section of the deployment. I've changed my mind about it. And it's way easier to script that and to do that than trying to edit files and reapply them. So now if I go in, you can see that it's going to change the name. I go in and you see instead of getting a 404, I've got that ingress rule. And if I go back, give it a sec, you can see that ingress is true now where it was false before. And that's from the status, right? So I changed the spec, and it seeked the state, and it re-reported, well, actually, this is true now. It's no longer false. You've changed your mind. And you can see, okay, that actually went through and it all worked. More importantly, let's break something. Let me delete that service. If you'll notice, there's still two. The only way you can even know that I deleted the service was this one's 8 seconds old instead of 3 minutes or whatever. Because the moment I deleted it, Kubernetes said, okay, that's right, WIGM GIF, you wanted to watch all the things made by a WIGM GIF. This service was made by this WIGM. So I'm going to throw that to the operator, and the operator says, oh, yeah, no, there's supposed to be a service there, and it tells the cluster to put it back. And so it's basically impossible for me to have the service be deleted, and it'll immediately come back. It's going to seek the desired state the moment that it changes. This is why if you're in Kubernetes and you're working on a pod from a deployment and you delete the pod, it comes back immediately. It's because there's a Kubernetes operator saying, no, there's supposed to be 2 of those, right? Like you have to change the declaration of the desired state not just the desired state. So,
Service was defined in Python code, right?
yes, it was.
So where did you tell it to watch to make sure the service was still there?
That was the Metacontroller configuration, where you said, made a custom resource, said Metacontroller, watch WIGM gifs, and watch the child things of WIGM gifs.
Anything that was created under it, okay.
Yeah, and so, and Metacontroller actually ties that all together. It does a bunch of, it creates the Kubernetes resources to say, this service is owned by this WIGM GIF. It kind of does that linking automatically, and the Golang controllers don't, and you'll see how we do that manually in a second. In fact, because I think this is so cool though, let's go ahead and try to get rid of that service. I don't think I can, well, there it's gone for a second. Okay, it's back. So if you try real hard, you can break your thing, but you have to like have a concerted effort to keep your things broken with state seeking. And if I wanted to get a little fancier, just to show you, we could come into our WIGM GIF, and I could change my link name. And I've done it by recreating the entire YAML and throwing it into the cluster. We did it with kubectl patch command. This is using an interactive edit, which I don't, which has plenty of usefulness. If we were to go in, you'll see that it did, in fact, like I did an edit and I seek state. So you see how this gives you way more confidence in operating on your system. Like you don't have to go figure out all the things that you need to change the name. You just go into the input, change it any way you want, and the only tool I have to have now that I'm in operator land is Kubernetes API access and some Kubernetes API tool. So let's move on to the kind of where it gets to the absolute best form of this, which is the Golang operator. So I think that, yeah.
So let's say, right, you have hundreds or thousands of these things up, and you decide, you know what, I want to have an Envoy instance instead of NGINX. What does the deployment where it's like, I'm now going to impact every one of these I ever made?
Right.
What does that story look like?
That depends. If you change the operator code and run a new version of the operator, when it starts up, it's going to resync its state, and it's going to sync them all at the same time. So what I do, and that's sometimes desirable, but most of the time it's not. So usually what I do is, if I'm going to do, like, sometimes maybe that's fine. Like, depends. So if I was going to do this, and I had WIGMs that I'm doing rolling updates all the time anyway, like that's just another rolling update. Who cares if they all go at once? Kind of depends on how hard it is to, like how hard it is on the CPU starting up, but maybe that'd be fine. You could try to write some locking in there, or what I typically do is I go add a field to the custom resource and say, should it be NGINX or should it be Caddy, or like I'll actually go
definition.
Yeah, and I'll keep all the everything that doesn't specify that field with the default behavior, and then I'll willfully turn on a new feature one by one in the resource.
Change the kind of a custom resource? Can you just be like, no, this is -2, and then
You can't, but you can change. You can add specs to it. You can add fields.
you can add fields, but you can't take something that's a certain kind and something else that dash envoy.
No, but you could create a version 2, and that's great even more. Like typically, adding fields to a custom resource doesn't hurt anything, depending on your code, but mostly it doesn't. They do have some versioning of custom resources.
Change the spec version though, right? Like, because that's what they do in Kubernetes, is those spec versions that go from.
They do, and you can do it with custom resources, but it's a lot more work to handle multiple versions.
Metacontroller doesn't.
No, because what goes on in Kubernetes when you put a deployment v1 or a deployment apps beta v1, when you send those Kubernetes API, it actually runs them both through a function to generate some sort of what they call an internal version of that object. So they say, here's all the different versions that we handle with their different specs, but no matter what you do, we're always going to convert it to the lowest common denominator and then back to what you asked for. And so if you want to do your own custom resource with multiple versions, you have to write that conversion code yourself. And it's getting better, like multiple version custom resources are getting better, but they're still not great. But you can add, I add things to specs all the time. I've used that like crazy where I just say, oh yeah, now deployment type equals, and unless it says caddy, I'll just keep the old behavior. So like I said, with everything, there's nuances, like you point out, like if you want to run the thing, there's decisions you have to make, because it's going to try to, this is like, imagine if Kubernetes changed how a deployment works. the moment you update the part of Kubernetes that does deployments, it's going to seek all the deployments to the new state. That's just the nature of state seeking infrastructure. Yeah. So let's move on to the final phase where we build our operator with Golang and the Operator SDK. And this is my favorite form of this because it's the most powerful. It's insanely powerful. It's no matter how cool it is, no matter what the language is, it's the same pattern. It is watch, seek, and report. The difference is here, there's no Metacontroller injecting itself all over the place. It's the operator. The only dependency I have is the operator talking to the API, and there's no other tools that I have to depend on or use. But it's still the same thing. Watch all the resources, seek desired state, report where you're at in that process. If you're going to run it, you either build it and run it locally, or ideally, when you're deploying operators in a Kubernetes cluster, typically you're throwing some YAML at the cluster. If you could go deploy the etcd operator, Vitess operator, you're just going to put that into the cluster, and somebody's already built some YAML, and you run it, and you can start operating on these custom resources. I'm going to show you how you build an operator with the Operator SDK from scratch. And I want to point this out because if you're doing this with raw Go, it is not nearly this easy. It's a whole giant pain in the butt. But with the Operator SDK, it's as easy as saying Operator SDK. That's a tool that you have to get from their GitHub. Create a new operator called WIGM, and it will spin out a whole bunch of infrastructure for you under a folder called WIGM. If you go in there, it's got a bunch of things. The first thing I'm going to point out is that it has already made all the YAML you need to deploy your new operator into a cluster today. It gets done. It says, okay, here's the YAML to put this operator. It doesn't even do anything yet, but you can deploy it into a cluster right now. That's great, but I need to have an operator not just exist doing nothing. I need to tell it that WIGMs exist as a resource, and then later I'll need to tell it, not only do WIGMs exist, but I want you to be in charge of them. So this is part one where I say, okay, Operator SDK, I want you to register a new API called WIGMs, and of a kind WIGM GIF. And this is kind of that same stuff that's at the very top of all those custom resources we've been looking at. And it'll spin off a bunch of things. The first thing it does is that it actually goes into your deployment and says, okay, well, let me make the custom resource definition spec for you. That kind of very repeated, ugly YAML that we put into Kubernetes to say, expect this new kind of thing to now exist. It generated that for us. And it updates the role for the deployment. Says, well, you're probably going to need to have access to these if you're going to work with them. So all these kind of things that trip you up when you're doing it yourself, they're automated in the SDK. It also, way down in this package folder, creates this WIGM types file. And I want to go into that because this is where we're getting into finally strict typing of our resources. So at compile time if our operator is working on valid resources or if it's going to try to treat things like the types that they're not. If I were to go in there, this is a whole bunch of Go code. I don't know how familiar everybody is with Go, but I'll kind of point out the important parts here. We are strictly typed now, but if you kind of squint, this is that same spec that we've been looking at in the YAML. We've got a GIF, which is struct GIF properties. Inside that is a name and a link. We've got our service. Inside that is a service cloud load balancer Boolean. The difference is this is a more verbose, kind of fully typed definition of that, but it's just the same YAML we've been looking at, just telling Golang how to understand it. I also want to point out, and this is in red because it's not in the code, now that I'm in Go and that Kubernetes is in Go, I can embed in my own custom resource definitions anything from the Upstream Kubernetes API, right? So if I want to say, okay, well, inside this service section where I've got the service block of the YAML, maybe I want, when you deploy a WIGM GIF, for you to just put the whole service definition inside of that section. You see this a lot. In Kubernetes right now, if you go make a deployment, there's a little thing called spec lower down in where you put there's spec, then pod template, where they've embedded the pod template definition into the deployment spec, right? They don't copy and paste those types, they just embed them. And once you're building with the Golang operator, I can take those upstream definitions of things and put them in my own resources. A more kind of easy example to understand is, say I'm going to have WIGM GIFs, and instead of making a deployment, I want you to put the pod spec in the WIGM GIF, right? So just put the entire definition of what the WIGM pod should look like inside your custom resource. If I was doing that with YAML, I would have no, or if I was doing that with Metacontroller, I'm in Python and there's no sharing of types. But I'm in Go, so I can just embed the upstream information into my own custom thing with one line. This is super useful for my other, I'm going to just keep plugging my own stuff. Kubevalet is another tool that I wrote that does Kubernetes scheduling. And one of the things in Kubevalet is the section of a pod spec that tells Kubernetes what the scheduling rules are for that pod. Because that thing was ready to go, I could just not have to recreate the possible things that could be in that definition. I could just embed them. Let's go on. So we've created a new operator. We've told it that WIGM gifts are a thing, and we've created and fleshed out what WIGM gifts exactly look like. But we still need to tell the operator, watch WIGM gifts and do something about them when they get created. And that's where we say, okay, I want to add a controller into this operator, and that controller is going to watch WIGM gifts. So again, another command is going to spin up a bunch of code for us. Primarily, it's spinning up this WIGM gif controller.go file. And really, the only thing you have to do in that file is go edit your business logic of what it means to deal with a WIGM gif. So if I look in this is pseudocode. Just to give you an idea, because I'm not going to show you all the Go code, because it does get more verbose. The farther we go down this, if you haven't noticed, the YAML was pretty straight. Helm got a little more complicated. The Metacontroller stuff was not too bad. The GoLink stuff it's more code. It's just the reality of strictly typed stuff. It's just, there's more to it. But it's essentially the same thing as Metacontroller. We set up a new controller at the top. We're going to set up a bunch of watches saying, hey, this controller that I'm making, I want it to watch WIGM gifs and watch every child deployment, service, and ingress of that WIGM gif. And then every single time one of them changes, try to synchronize the deployment object for that gif. If it fails, handle that error gracefully. And I'm going to say that again because this is where no other thing but writing your own controller, nothing else can handle that. If you're using Helm and you throw a bunch of new resources at a cluster and half of them fail, Helm has no idea what to do. The only thing you can do is keep pushing forward. Keep pushing the changes and hope you bring it back into a good state. If you're using Metacontroller and it tries to create a bunch of things in the cluster and half of them fail, the only thing you can do is keep going forward, because so far every other tool we've looked at is just basically a fancy way to make a big blob of data and throw it at the cluster and hope it works. When you're building your own cluster, you get to step through every piece of it. Or sorry, when you're building your own operator, you get to step through every single phase and deal gracefully with your failures. So if I try to make a deployment and it fails, I can just error out, put some information in the status section of my resource in the Kubernetes API and stop, right? Or if I get or I can decide to keep going forward. It's my decision anytime any of these fails, what I'm going to do about that failure versus just try to throw it all in the cluster and pray. And I think this is really where the power comes in, because it gives you really graceful and precise control over exactly what's going to happen every time a thing changes. So we sync the deployment, handle gracefully, sync the service, handle failures gracefully, and same thing, sync the ingress. And it can get way more complicated than this. This is the simplest possible version, but you could do all sorts of things. You can do really fancy custom rollouts. In fact, every sort of system you look at for Kubernetes that does like blue-green rollouts or canary deployments, they all end up implementing an operator of some kind, because that's the only time you get low enough to really deal with everything you want to deal with. If we go further in, this is where we do that first part of the pseudocode where we create a new controller, and we're saying watch WIGM gifs, and we're going to say watch all deployments created by a WIGM gif. So a lot of Go code, but it boils down to the same thing from the metacode that says watch WIGM gifs and watch all the child things. This is that sync loop from before. We're going to say, okay, try to sync the deployment, fail gracefully, sync the service, sync the ingress, and then at the very end, we're going to update our resource status and say, okay, here's the state of that progress. Also really cool about writing your own controller is you can do this stuff in phases now. And you can do that in with Metacontroller or really any operator. But I could say, oh, you just changed this part of your custom resource. That means phase 1 is sync it to this state. And then once that's all done, phase 2 is sync it to this next state. You can have these kind of intermediary steps in a way that you just can't do that with Helm. Like, you would have to manually, if you want to have your Helm template go from A to B to C, you have to go Helm apply to B. Wait for it all to finish, like watch it yourself, and then Helm apply to C. There's no way to kind of like have these actual processed steps. But now I can do whatever I want. In this case, I'm keeping it really simple. This is that same deployment that you've seen the whole time. It's getting uglier because it's all strictly type and go, but it's not that bad. We're still creating a deployment. There's still metadata with a name and a label. There's still a deployment spec with our environment variables. Like, it's the same thing we've been dealing with. This is just a bit more verbose. I like this though. And the reason I like this, not because it's more verbose, but because if I try to put an integer where it's supposed to be a string, it will not compile. I won't have to wait till I try to apply it to prod later. When I try to compile this code in Go, it'll say, that's not even what a deployment looks like, dude. And I won't actually push bad code. Metacontroller can't help you with that because I can write bad Python code, create invalid objects, and throw it back to Metacontroller, and all it can do is freak out. You'll never know until you actually try to use it. But once we get strictly typed and we're compiling it ourselves, we get all of that type safety. If we go further in, we've got our if condition for our service. Again, our business decision is never left in if condition once we step away from YAML. And then as a really cool advantage, once we go into Operator SDK and we're in Go, we have this fake Kubernetes client. So I can write unit tests against Kubernetes for my operator, and test all these different functions, test the whole process end to end, without even really needing an actual Kubernetes server anymore. And you just don't get that. Metacontroller and Helm has a vague idea of a test, but it has to operate on a real Kubernetes cluster. And maybe Metacontroller has something, but I mean, I'm using the, when you're in Go, you get the official Kubernetes fake client, and you can write your operator tests against that and write better operators. So let's do our final operator demo. We're gonna bring it up. You notice there should be fewer things this time because I don't need Metacontroller. I only have one section at the top now instead of Metacontroller and my operator. Like, there's no third party anymore. It's just the operator. Give it a second to come up. Shouldn't be too bad, but it does. There we go. There's my operator. Here's my WIGM gifts output from before. Like the operator. In fact, I'm going to start the demo before the operator's ready. I don't need the operator to be up. I can actually start. In fact, actually, let's do that. I'm going to explicitly delete this and we're going to go from scratch again. So when I wanted to work with Helm, I had to have Tiller ready. I made explicit note when we did that Tiller had to be in the cluster, and it had to be ready. Because I'm not talking Kubernetes, I'm talking to this third-party service that if it's not there, it can't work. Once I go to operators, I don't actually care if the operator's processing. I can put resources in the API, and when the operator starts, it'll process them. I don't have to make it when it's up. So let's actually do that. Let's bring up our operator, put things in it before it's even ready to process them. So I'm going to run my demo. I do have to have Kubernetes up, so give that a second. Okay, so I'm going to do my first release. Control create. Notice the WIGM GIF exists. Everything's still to none because there's no operator operating on this. I could put in 10 of them. I can put all the resources in the world that I want. But as soon as my operator comes up, and as soon as it's going to reset and look at the current cluster state, and the first thing it does is try to sync everything exists where it wants it to be. So as soon as that ready's up, give it a second to actually pull the image. You'll see the WIGM GIFs stop being nuns, and all my things existed. And I didn't have that strict dependence on this tool existing. I can deal with it, and I can swap out the operator on the back end and not have to worry like, oh, I'm going to do an upgrade right now, so nobody put a new resource in there because the operator won't exist for a couple minutes. Like, you can handle that downtime because it's just a few minutes where you're not seeking state, and it's fine. So now it came up, it updated my status, so all my things are filled in here, and my WIGM gets got deployed. So we come in here, do our second release. Again, this is the same process we did with Metacontroller. It's just doing Go now. And it came up. All that works. In fact, we've already seen this, again, it didn't actually matter. Like, I like the Go controller for a more reliable, testable experience. But I'm not going to finish the demo because this is the same thing as the Metacontroller demo. Once I moved into the operator, I don't actually care at all which operator it is. I get all the same benefits of just the Kubernetes API, all the ease of updates, and just the kind of the state seeking awesomeness. So I won't even finish the demo, I'll waste your time. I want to have time for that one last cool demo. So that's cool. So now it's really easy for me to make these things, delete them, change them, and have the cluster immediately go to the state that I've desired without having to care about what that means to actually do in the cluster. So we did WIGM a bunch of different ways. We started out with YAML, we moved on to Helm, and we went to operators. Again, you're probably always going to start in YAML. There's nothing wrong with that. Helm is fine, but I mean, once you, and I'll also point out that each of these, as you go left to right, are kind of more and more useful as you get more and more stable, right? It's, if you're really changing a lot, do YAML. But once you really have locked in, say, here's what we're doing, we want to really tightly control this and not make it as easy. We want to make it more reliable and easy to do a lot of them, but maybe we're not changing every single day. Then that's really where it starts to benefit you to move farther to the right as you kind of stabilize what the definition of your thing is. Doesn't mean you can't have an operator as your like bleeding edge, but it requires more and more experience with operators to have them at the very, very edge. Often I find myself just developing a bunch of things with YAML, and then once I figure out what I want, then that's when I go write the operator to make the resources. I also kind of took the liberty of coming up with my own opinions about what things are good for what. I will point out that really the only downside of the Golang SDK is that there's a kind of learning curve getting into it, understanding the Kubernetes interfaces, and understanding Go if you're not super familiar with Go. But like, if you are, it's just about the best way to do almost anything but rapid development. So that's it. Like I said, I want to do one last thing at the end where we can show you how we turn our Helm chart into an operator in a single command, because they just added that to the Operator SDK. Did someone say boo?
Ooh.
Oh, okay, they said boo. Ooh, that's cool.
Super cool.
Keep Helm pure.
Right. So that's the source code for the presentation. K3S is what I use for all my demos, and KDS is a tool to deploy that in Docker without having to write Docker compose files. So there's a couple tools that build on each other there, and some of my other presentations and whatnot. Let's go do that last demo. And I'm going to do it without pre-typed demos. So let's really hope this works.
No safety net here.
Yeah, no safety net at all. So I'm going to do K3D, create workers. And I did not create K3D. That is a rancher tool that uses another rancher tool. But I'm going to spin up a Kubernetes cluster. And there we go. So I've just spun up a Kubernetes cluster from and there's no, if you look in the directory here first, the only thing I really have to do is export kubeconfig to tell it to point to the information for that cluster. And I've got a working cluster in Docker on my machine. There's no Docker compose files. That wasn't a bash script. There's nothing in here but a bunch of junk that's not a Docker compose file. I've got a new cluster. I can do kubectl get nodes. And there's this is the coolest way. I love this because I'm trying to figure stuff out in Kubernetes all the time, and I don't want to mess with a dev cluster, a prod cluster. I want to create a cluster from scratch. Yes. Sure. Yep. So it made some and set some up for you. I love it. Like, it's really cool. If you wanted to delete it, you can do a K3S del and it deletes it, right? And it's designed to handle 2 or 3 different ones at the same time if you want. But so now I've got an empty Kubernetes cluster. I'm in my WIGM source code, and I want to turn this WIGM Helm directory into an operator. So I'm going to do Operator SDK new. Since I don't remember the flags, we're going to call it WIGM Helm operator. So the first thing I have to do is get it a name. Then I'm going to say dash Helm chart equals WIGM Helm. So I have to tell it where the Helm charts are, and I have to say type equals Helm. Again, flying by the seat of my pants here. So I'm saying operator SDK new, give it the name of the operator, give it where the Helm chart exists, and what type it is. And there we go. I've made an operator from my Helm charts, a complete, full-fledged operator that will state seek my Helm charts for me. I'm done. Let's go run it, because I'm going to show you.
On the CRD, like,
I'll show you. It's really cool. So now I've got this new folder based on the name that I gave it, a WIGM Helm operator. If I do a find in here,
Sure.
you can see it did the same thing operator I expect from Operator SDK. It made a deploy folder with all the things I need to deploy my operator. It made this custom resource definition. If I go cat that, it does its own, right? When I made my own custom resource, I made it under my own domain. When you do it with the Operator SDK, it takes the liberty of namespacing things in a certain way, but it's still saying, okay, yeah, you've got WIGMs now. So if I were to kubectl create -f, put this custom resource into a cluster, now I can kubectl my brand new cluster made from scratch. Kubectl get WIGM, right? And there aren't any, but it didn't give me an error that WIGMs don't exist. Right? Like, WIGMs now exist, they're in the cluster.
so the spec is based on the values files? Or
Yeah, I'll show you. that's the next one. So if I go look at the sample, it takes the default values file and says, here's what one of these is going to look like if you make it. So if I want to deploy one of these, I'm going to copy that default, because I don't want to use defaults, I want to override them. And I'm going to go over and say, well, my name is Yay, and my link is, oh, I don't know. Let's do it football. I don't like football, but. I've been told people like sports. Okay, there we go. Okay, put that in there. And I'm going to leave all my other default decisions. I could take them out if I want, but essentially I'm making my custom resource before. The only real difference I'll point out is that the charts, it's now under this charts.helm thing. Again, just because that's the way they work. Now, if I were to Operator SDK up local, this is going to fail. Don't be surprised. If you want to run it local, like it made some deployments. I could build a Docker image, push the Docker image, and then pull it back and run it. But if I want to run entirely locally, I have to do one thing where I link in the Helm charts into where the operator expects them to be. So this is pretty normal. I'm going to create a link to actually make a directory. Because the operator, when it runs, expects to be in a container. And because it's in a container, it's like the Helm charts are always going to be in this place. So I'm going to kind of cheat and say, sure.
You pointed at an actual like repo.
Yeah, absolutely.
So like it's because you want to run it locally. That's a little weird. If you had an enriched repo already.
Yeah, I think that's no big deal. But yeah, I'm trying to do it entirely locally. So there we go. I got to make that directory. I got to do an ln. And I need to link Helm charts WIGM to opt Helm charts right or wrong. I got to sudo that. Okay, now if I do an up local, now when it runs, it'll actually be able to find those Helm charts it's looking for. Or not. Oh, yeah, when you make links, it turns out you have to make valid ones. Do this. There we go. There we go. Double directory, but that doesn't matter. Okay, so now it's up. It's running the entire thing locally. It's pointed to my local Helm charts in that directory. I've just linked it to where it expects them to be. I think they're going to make, this is really new stuff. I hope they make it to where you can just give it a flag and say, look in this directory, but right now that's how you have to do it. If I were to pull up a new tab and Q control create, export to that test file, there you go. There's the operator, that Helm, my Helm chart is now an operator.
So instead of running the operator in a container, you're running it as a local process right now, similar to like a Go.
Right.
Or Go build.
Yeah, but you could build it up and just deploy it as a container. Again, it's all local, just to not. But you can turn your chart, package your charts up as an operator, and then it's even cooler because it's actually state seeking. So if I go in here, notice here's my spec. Also notice they do this thing where they put all of the objects that Helm rendered into your YAML. This will fall over if you have giant Helm charts. Kubernetes, a single Kubernetes resource can't be larger than a megabyte. So this works to a certain scale, but it works for our case. If I were to go say, instead of yay, I want this to be really yay. Save that, and I do a get all. You're gonna see this is a Helm chart, but I've got this cool automatically generated operator on top of it that I'm running that is state seeking my Helm chart. So you can kind of, again, I don't get graceful failure. And I don't get like kind of the nuances of being fully in code, but I get a lot there for no work. For running a single command and then a bunch of stuff to make it run locally without building an image and pushing it to the cloud. But
Locally, is it just connecting via the Cube API?
Just Kubernetes API. Yeah, for me, it was my local one. But normally you would, and you could do Operator SDK build, and I could say this is Carcinoid / WIGM Helm. And it's already made a Docker file. It knows how to build my Helm charts into a distributable package, and I could push that image out to the world and then use the deploy files that they've made. The only thing you have to go is tell it what the image is going to be, because it doesn't know when you generate the operator. So I'd go edit this to be Carcinoid WIGM, and then I can kubectl create that in a cluster and start running WIGM immediately, because the operator is built, and I didn't have to do any of the work to figure out how to build it or how to run it or just editing Helm templates, but I'm getting some of that state-seeking goodness out of it. So I didn't know that this is relatively new to the Operator SDK. It's a cool tool. It does something similar with Ansible, but I don't have enough experience with Salt Guy, so I don't have enough experience with Ansible to like smartly play with it. But like the Operator SDK toolkit really is like, we want people to build operators because they're a better pattern. We're going to make it easy to do that no matter what language you're in and what you're already doing. So there you go. So that was kind of the bonus thing that I just figured out as I was going over these demos lately, and I thought this just blew my mind. One command, got a functional operator from Helm charts, and that's it. Sorry.
I'm sure if there are any questions, we ran over, sorry guys, but I was pissed. I looked now, I went, oh man, it's past 7:30, so.
It's 30 minutes past.
So, go if you need to, be safe going home, otherwise, you can stick around here, have questions, whatever, just, we're here for a while, I guess, right? Oh yeah, stay long as you want. So, thank you.
Eat all kinds of food.
Stickers, don't forget the stickers.
So you have 1,000 WIGM CRDs.
Yeah.
How do you manage your CRD stickers?
Oh, the custom resources? That's a good question.
Let's say you want to add an exclamation mark to all of the titles.
Yeah.
Like, what would
What would I do? I mean, you could. I could control the patches, maybe you know the patch. I'd write some code because it's Kubernetes object, right? So I might write some Python code or something.
If people want to add that exclamation mark that aren't kubectlers,
Right.
I would use Argo CD.
Actually, you can.
Okay, so you have a Git repo,
Oh, yeah.
all your CRDs, and then you just change them all in the set.
Yeah, and you can build custom resources. Like you could have a custom resource that makes custom resources. Like that's really common. I mean, again, Kubernetes is doing it. You make a deployment, makes a replica set, makes a pod.
That's your help.
It's all the same. You probably did the mistake thinking it's easy to type. It doesn't need to be a different type.
so why didn't you take the
Operator Helm thing. Sorry.
and then Jared is throwing charger for a lot. When does we get the repo?
They actually use the parser for Helm to create the Go code then? Like, is it scaffolding out the controller? And could you go in and change any line of the code that it makes? Or is it like this?
I think it's just
Helm operator?
Helm tool. I think it's just running Helm in dry run mode, putting it in a cluster.
Oh, okay.
So if you have a really complicated Helm chart, one is going to explode beyond
Beyond the reason.
But then two, like it might create really bad code that you can't even go in and fix. It's not like going to help you if you wanted to make one manually. Like it's going to give you a good cookie cutter for really simple things. You can't tweak it.
No, it's only for like I have these.
You'd have to like tweak their actual code to spit up. It's more like a compiler than a scaffolding tool.
Yeah, it really is. It's
Yeah. Where'd Utah? That's right. So that's you.
what?
Like, right, clients, or we're talking about like, we want every app, every service we run to be a CRD.
Right.
There's always a trade-off.
Oh, there's always a trade-off. It's speed of development, right? Like you suddenly have to go like edit your operator and have, it's a new thing that you're dealing with. The versioning is tricky. Like I said, the versioning is still not great. So you're getting better. I didn't show it, but I would highly encourage you to do the open APIs validation in your custom resource. There's a field where you can say, when you try to put this in API, validate it, make sure it's what I expect. That I expect, because now it'll take any generate. Code might explode if you values, right?
When it explodes, you have to watch the logs coming out of the operator container. And if you wanted to do a breakpoint in there, you'd have to run it like you did the local run, where you're like patching yourself in. So like you can set breakpoints, but you're then no longer running real time-ish. Like you'd have to.
Yeah, it gets.
That's cool.
I inevitably ended up like running. I stopped the cluster operator for a thing, start a local one connected to that cluster.
I didn't know that command. That was so super.
Oh no, yeah, because SDK upload that set of things. So yeah, no, that's the downside is versioning still kind of sucks. So mostly I only ever add things ever.
Do you have events on your operators? Like, are you spitting out events so that if it gets to be really complex, like at least you can see?
I haven't put it in there, but I mean, you got the Go running with Metacontroller. I don't know if you have a service. It does some events for you, but in the Go thing, you can just fire off events with the event API.
On the new one, versions of version. So you define all your types in Go struct, and then you can run a generator for the open API.
Yes.
And it will put validations into the Kubernetes spec. So if you tried to apply it with kubectl apply this new CRD,
And validation.
it actually validates it for you and says, no.
Like, really do that, because but without it, first of all, it sucks. Like, what drove me nuts is they're like, okay, here's custom resource definitions, write an open API spec here, and the API will validate it for you. And so I had to write the open API spec and the Go struct. So like the same, like they had a way to render one from the other, but it was only for internal consumption for like forever. Now, yeah, do that, because otherwise that's what happens is operators like you put a list where a string's supposed to be, and the operator in Go at least explodes. In Python, it does something you don't expect. It'll just make 10 of a thing string now instead of listed.
Have you heard of the Kubernetes operator Pythonic framework? So we had somebody write it using the Go the SDK, and it exploded in complexity real quick.
Yeah.
To the level that like we were trying to solve telegraph, and like it was no longer recognizable as like doing stuff simple. And we saw it's from Orlando.
I'm trying to manipulate that.
Like they just make a little, so it's kind of like Metacontroller, and it gives you more access into more of the nodes. Instead of one service, like you have pretty much before. Then you write in Python.
So yeah.
All our guys know Python.
No, and I don't blame anybody. Like I really harp on people. Like, and you can also write an operator.
I immediately look for a JavaScript.
The difference is you have to build the whole thing from scratch, right? So
This sounds like an open, it's like the SDK that you have for Go that comes from, like, that's the one that everybody's using, so it's really well refined. It's not as old, but it seems like the way the Python community's trying to solve it.
there's nothing that makes it impossible to do it anyway. So the hardest thing you have to do is figure out how to do the etcd by watching, like have a local cache process event.
So this is, I saw this, last March or something, you gave it, and like now I actually understand it. So it's really nice.
Because you've actually done some of it, right?
Like I've actually seen the bits.
You find this cool.
I love it.
Not the same sort of stuff.
Even though I think they pull it production for that.
Oh my gosh, they really are. I can't say it. It's not gonna say it. So, I love it. You need a shave. Sorry.
That's not, it's like being a
I was just gonna say that, but I was like, he doesn't actually know sports. I was gonna say, did you have a meeting today, or looking like real?
Tell them we.
I'm the coach, so he tells me I have to get haircuts.
One operator fixed
So many words.
You've been saying like,
I was like, do you want to? She's like, do you want to?
I really like that. I like actually saying like
You start acting like
put it in your cluster bootstrap, because then
Really? Is that what you already have?
that's where he goes like X, Y, and Z new things, and they always put it all the time.
super happy about it.
Yeah, I noticed install more than that.
If you have 10 operators out,
So,
like, a tiny bit of resources to run. Yeah, but like they're not holding the API and causing any pain. They're just carrying.
so that show thing.
I'm texting my wife right now, actually.
I mean, I won't tell, I won't tell my wife.
I think my wife's on the same page as your wife, so have a conversation.
Come on, who got that? So I don't put my post too.
I have no idea what to do with Redmond.
I'm not the one like mainly doing it.
Mostly happier.
Editing in Red Rock because we thought we'd be able to do it.
The most experience I've had is with their third-party tools, like not their own products, but that is like. I looked at like the best ways. Google Cloud. Google Cloud got, unsurprisingly, like it's a Google-funded project. They've got the easiest way to get it.
Deleting code.
No headaches.
Yeah.